Pay attention, please. Okay? This one only has two terms, but there is no greatest common factor. Okay? There is two terms, but there is no greatest common factor. You will eventually probably solve this using square roots, but this one is factorable. Okay? This one is factorable.
Oh.
It's called the difference of two squares rule. Difference of two squares. Okay, difference of two squares. This is a special factoring rule that will show up quite often. If I have a perfect square minus another perfect square, it will always factor to just simply a plus b, a minus b. So be on the lookout for a difference of two perfect squares. Is x squared a perfect square?
Yes.
Yeah, because x times x makes x squared. Is 36 a perfect square? Yes, because 6 times 6 makes 36. And is it subtraction? Yes, so this is the difference of two perfect squares. So this will factor to what?
X times
X plus 6,
X minus.
x minus 6.
What do you do if it's addition?
You cannot factor it if it's addition.
So what do you just do?
You'll end up solving by square roots and you'll get an imaginary or a complex solution, and we'll talk about that later.
Alright.
It won't happen today.
Okay.
But it's coming, yep. Good. What do I do with both factors?
set them equal to 0.
Set them equal to 0. Okay? Any questions on? I got one more to show you. Okay. This one's a little tricky because now I threw a coefficient in front of the x squared. It's not just x squared. I'm going to show you a couple ways you can do this. On the majority of them, I will always just do the guess and check method. I'll show you what I mean right now with that. There is a longer process that will work every single time, and some of you will definitely like that. I sent you a video of that one. But typically, I'm just going to go through this process. I looked at all three terms and I asked myself, is there a greatest common factor? Do all three terms have anything in common?
No.
No. Okay? Alright. So I can't pull out a greatest common factor. So I'm just going to go ahead and make my two sets of parentheses.
Why is there only 2 if there's 3 numbers?
When you multiply them back together, like I showed you on that previous one, then it'll end up being 3 terms. And here's how my thought process works. What times what gives me 2x squared? 2x and 1x? 2x and x? 2x times x would give me 2x squared. Now, this number times this number does have to equal negative 15, but it won't add to 7. Okay, that method doesn't work anymore when they throw a 2 in there. So this is where you do have to do a little guessing and checking, or use the process that the video talks about that I said. Okay? So these two numbers have to multiply to negative 15. I'm going to guess wrong on purpose here right now. Okay, I've already done, because you might guess the wrong one. I'm going to try a negative 15 with a positive 1. Okay, let's say that's my first guess. How am I going to check to see if I'm right? I'm going to distribute it back out. 2x times x gives me my 2x squared, so that part's right. 2x times negative 15 is negative 30x. 1 times x is positive 1x. Do those two add together to make 7?
No.
No, so those are wrong guesses.
You just said yes.
Alright? I'm not going to use 1 and 15. How about 3 and 5, right? Let me try that one. So, 2x squared, that's good. Minus 10x plus 3x.
Yeah. Now that.
Yeah. No, that's negative 7.
The only problem is that's negative 7x. Well, that means you're really close.
So negative minus 3.
Make that a minus, make that a plus. Now you'll have it because it'll be a positive 10x and a negative 3x.
And then just equal those.
Minus 3 plus 5.
So then what would do next?
Now I'm done. Now I know I factored
Make
it.
them to 0.
Set both factors equal to 0 and solve.
When you have a multiple that's equal to 0 on that last step, do you just divide like the 2?
Add 3 to both sides, right? Add 3 and then divide by 2, right?
Yeah.
I'm skipping those steps up here. I added 3 to both sides and I divided by 2. Here I'm just subtracting 5.
Why isn't it negative 3 over 2?
When I added 3 to both sides, I got positive 3 over here, right? When I added 3,
And then divide it. Yep, got it.
okay?
Do you want
So-
to simplify fractions when you do that?
Always just reduce them, this is fine.
Okay.
I mean, 1.5 is still fine,
Well,
but
yeah, I know that one's not going to simplify, but I just want to do.
yeah. I want to just show you this one. Don't always assume guess and check. Sometimes you can just take out a greatest common factor. See what I did there? I took a 2 out of every term. And now, that's easy because I can just go, what times what makes x squared? And then what two numbers multiply to this but add to this? And then I set all the factors equal to 0. You can't solve 2 equals 0. That makes no sense, so you just ignore that one and you just solve the ones that you can for x. Okay?